When you write processing programs, you are going to create tons of objects that hold integers. So let's talk about what these objects are, what integers are, and how you manipulate them. To talk about this, I'm going to use the example of cookies. So we've created a bunch of cookies, we've baked them, and we have cookies of various kinds. And of course, we have different numbers of each cookie. We might have 10 oatmeal raisin cookies, and 5 sugar cookies, and 8 snowman cookies, and so forth. So we want to be able to associate a number with each type of cookie. And we might have many different types of cookies around. So how do we organize all of that? Well, first of all, we give every type of cookie a name: sugar cookie, snowman cookie, oatmeal raisin cookie, snickerdoodle, which is a great name for a cookie, and we assign it a number. What kind of number? A counting number. 1, 2, 3, and so on. Just the good old familiar counting numbers. And if you remember your Sesame Street, Count Von Count walked us through the numbers. 1, 2, 3, and on it goes. Well, in the computer, we also add 0 and then negative numbers, just for completeness. So we can represent any negative whole number, the number 0, and any positive whole number. So what do we call these? We call them whole numbers or integers. Integer comes from the Latin for whole number. So it's a synonym, but it's shorter and easier to type. And so we use it in programming. In fact, we're not even going to really call them integers when we type them, as you'll see. We're just going to use the first 3 letters. We're just going to call it an int. And in fact, you hear people refer to things as ints. And what they mean is integers. And by integers, they mean these numbers, numbers with no fractional part. A negative number, 0, or a positive number, but just whole numbers. So let's look at a bunch of them. As I've said, 0 is an integer. 42 is an integer. Here's a huge integer. Now, if you're in the United States, you're probably used to writing a big number like this using commas. You might write 489, 327, 148. And in other countries, you would use different punctuation. In processing, we don't use any punctuation like that in our numbers. If you have a big old number like this, you just write it down. Don't put in the commas. Processing won't understand them, and in fact, it'll give you an error message. Now, how big can this number get? Well, processing is happy to store a number for you up to 2 billion. That's billion with a B. You will normally never come anywhere near that upper limit. That's just astronomical. Typically, in our integers, we have numbers that are in the tens or the hundreds, maybe the thousands, because you're counting things. And if you have billions of things in your program, oh my gosh, I don't know what you're drawing, but it's going to take forever to draw billions of things, no matter what they are. So, or to do anything billions of times. So typically, integers are going to be just fine for anything you want to do. If you absolutely need numbers bigger than billions, there's another kind of number type that we will talk about later that will let you use even huger numbers. I've actually never needed it in processing in years because 2 billion is just an unfathomable number. I've never come near to needing it. Now let's talk about negative integers. Well, we can store negative numbers, just stick a minus sign in front. And you can write down a huge negative integer. And again, no commas. And again, we can go to negative 2 billion. So now that we know the range of the numbers, we know what they're called, they're integers. How do we put them into the computer? The answer is we're going to make an object. And that object will hold the number. And then we can open up the object, see what number's inside of it. We can change the number that's inside of the object, but the number is associated with the object. Think of these objects like toy cars that you might have in a car collection. You can put things into your toy cars, right? You can put little drivers, you can put little pieces of luggage, That's assuming that the door is open and the trunk's open. So what you might do is you might say, well, the yellow Camaro right now holds one female driver. And you take the Camaro off the shelf and you open up the doors and you put in some luggage, or maybe you put someone in the passenger seat, and then you put the Camaro back up. And now that same car, the yellow Camaro, has a female driver and a male passenger and luggage in the trunk. And you can keep taking it down and changing what's inside and putting it back up as often as you want. If you have more money, you can do it with larger cars, but the idea is the same. So let's actually do it. Here I am in a blank processing window. So suppose that I want to count the number of cookies that we have made, and let's say we've made star cookies. So I'm going to have an object, just like our yellow Camaro could have drivers. I have to give my object a name. So I'll call it number of star cookies, because even though I'm using 4 words, it all has to be one chunk of characters. I can't have spaces in the names of objects. And so number of star cookies. Fine. Now I have to tell the computer this is going to be a thing that holds integers. And the way we do that is we put the word int in front. And you'll notice int turned orange. That's the computer's way of saying, hey, I know that word. That's a special word to me. That's the word that you put at the beginning of a line to say what comes next is the name of an object that will hold an integer. Now, it's only int that it recognizes, all in lowercase. If I typed int with a capital I, it's a completely different thing. Capital I is not a lowercase I. It has no idea what that is, and you'll see it's in black. If I type int, but I keep going and I type integer, that's also in black. It doesn't know what integer is. It really is just int. So, okay, we've now said to the computer, I am going to create something to hold a number. It's going to hold an int. Its name is number of star cookies. And we're almost done. But one thing we need to do is to add a semicolon to the end of this line. You will see that almost every line in processing ends with a semicolon. There are times when you don't, and we'll talk about that later on when we get into programming. But for now, every line ends with a semicolon. It's just like in English, where every sentence ends with a period, or an exclamation point or a question mark. But every sentence ends with that piece of punctuation. Every line in processing ends with a semicolon. So, okay, I've just created the object, number of star cookies. And the computer says, I know what that is. That's an integer. Now let's put a number into it. And the way you do that is you say number of star cookies. And this is actually programming. This is real processing code. And something is going to go in here. And I'm just going to put some question marks to say something will go in there. And let's say we baked 5 of them. And then a semicolon at the end, because every line for now ends with a semicolon. So now what goes in the place of those 3 question marks? How do we say number of star cookies gets assigned the value 5? Well, some programming languages create a little arrow out of a less than sign and a minus. And that's meant to show you visually 5 gets put into number of star cookies. That never really caught on for various reasons. Almost every language in the world uses an equal sign. So the equal sign here does not mean equality. It doesn't mean these things are equal. It's not the equal sign the way you got used to it in high school. It's really conceptually like this arrow. It means assign the value of 5 to the object named number of star cookies. This is a real program, and we could even run this. In fact, we will when we pick up the thread in part 2.